Let's go ahead and get started. And first of all, Joshua, I want to let you know that we are praying for you and for your mom right now. Joshua will be out for the next couple of weeks as he is getting better himself, was not feeling well. So let's be praying for him. And Joshua, I'm not sure when you'll watch this. Hopefully you'll watch this at some point, but it probably won't be for a few more days as he works on getting better first. But practice exercise, or review exercise, number 16 is where we're going to be today. Review exercise 16. I want to take you back to something you learned last year in 7th grade. You talked a little bit about investments. You talked about stocks and you talked about bonds. And one day you may want to, if you make enough money, that you have some money on the side, you may want to invest. Remember, mathematicians are lazy. And what lazier way than to make money by doing nothing, right? Now, it sounds great, but before we start on the practice exercise, because I don't expect you to remember all of this, let's refresh what is a stock, okay? A stock is a certificate or a set of certificates that show that you own part of a company. So if Lana wants to start a company, and what kind of company would you start? You could start any company you wanted. Chocolate factory. That would put Willy Wonka's to shame, I'm sure, because this would be Lana's chocolate factory. And so Lana's chocolate factory, she's like, I've got these great plans, but I don't have enough money. So she says, Mr. Nadasky, would you loan me money? I said, well, if I can be a part owner. So Lana's like, tell you what, Mr. Nadasky, I will let you be part owner in the company for $100 a share. Which is not, that really wouldn't get her started, but let's just use it for sake of analogy. So I give Lana $300 and she gives me 3 shares of stock. I own 3 parts of the company. Now Lana has already sunk $10,000 into this company. So she already has 100 shares herself, right? She has hundreds, okay, $10,000. So I own 3 shares, she has 100 shares. If we disagree, who wins? Lana, okay, because Lana has way more than I do. Let's say she gets Scott to invest, and Scott puts $2,000 in. Well, that's 20 shares. So if Scott and I disagree over something, Scott wins. He owns more, right? Now, the idea behind investing in Lana's chocolate factory is once it gets up and rolling, let's say they pull in a profit of $123 at the end of the month. She gets 100 of those dollars. He gets 20 of those dollars, and I get 3 of those dollars. If she makes a profit of, I'm using easy numbers here, $246. 240 and 6 proportional amounts based on what we invested. And this is how businesses like Walmart work really well. If I look at Walmart and say, hey, they're making a lot of money. You know how I can get a piece of the pie? Invest in them. I give them some money, whatever that price is that they want to charge, I get some stock, and then as they make money, I make money. Now, it takes a while to make back your money. Because, Scott, if she only makes $246 that month, you only get 40 bucks. You invested $2,000. So if she keeps up at that rate, it would take you 50 months, over 4 years, to get your money back. But she may take off in just 1 month, she pulls in $100,000 profit. Now, probably a lot of other people have invested at this point, but if it's just us, and she's just a manufacturing, advertising genius, and she just explodes Lana's chocolate factory, not literally explodes it, and she's like, that's more likely, but it just takes off. Well, then now we're all divvying up 100 grand. Now, granted, she gets most of that because she sunk the most money in, but it's an investment that involves ownership. Now, here's the other thing. If she takes a loss 1 month, guess who has to help bail her out? Right? Now, let's suppose she's doing really, really well. Like, you know what? This thing's just good. I want more of this pie. I can keep buying more and more stock. So the more stock you own, okay, the more money you make off of a business that's doing well, but the more stock you own, the more money you stand to lose if the money is not doing well. So it says people often buy stock in a company as an investment. The other way in which you'll make money is you'll try to sell the stock off. So, for instance, Lana says, Mr. Dasky, I'll sell you stock for $100 a share. Like, okay, it's a startup company. I give her $300. I buy 3 shares of stock. Well, her company starts doing well, and suddenly everybody wants Lana chocolate stock. LC on the stock exchange in New York. And so I'm like, you know what, Glenn, you want to invest? I've got 3 shares. I'll sell them to you for $200 a share. And if that's what the going rate is, he spends $600 and I sell him my 3 shares. Well, I only paid $300 for my 3 shares. He spent $600. I just made $300. So a wise stock investor will buy stock. He's like, okay, I think this business is going to do great, but it's not doing well right now, so I can get this stock for cheap. And I think I can turn around and sell it better. Or maybe they're like, you know what? Walmart's doing great, but I think they're going to keep doing great. So I buy Walmart stock at $80 a share, and a couple weeks later, it's up to $90 a share, and I sell it off, and I get $10 per share of stock that I bought. Does that make sense? Now, the X factor in all of this is very few people are actually able to just buy stock directly. You have to go through the middleman. The middleman is called a broker, okay? And the broker charges a fee. So Hayden's over here like, hey, I'll handle all of this for you guys. Lana, you want to sell to this guy? Here, I'll sell to this guy for you. You want to sell back to Glenn? I'll sell to Glenn for you. And if we just all go through him, and every time a share of stock changes hands, he charges a brokerage fee. So he's sitting there doing nothing, he's like the bookkeeper. He's just keeping track of everything for everybody, and he's making money for doing that. Okay, and capitalism, great. Everybody gets to make money while she makes chocolate. All right, but it's okay because you can eat the chocolate that you make if you really wanted to, as long as your investors are okay with that. So this is the basic rule of thumb. The quotation is the price at which you buy the stock for. So she quoted me a price of $100 a share up front, but I turned around, and by the time Glenn was ready to buy, it was up to $200 a share. That's called the quotation. Okay, yeah, so the quotation is the price of the stock. You buy the stock and sell the stock through a guy called a broker, and he charges a brokerage fee. Now, think about it. If I buy 3 shares of Lana stock for $100, and I have to pay him a brokerage fee of, let's just say, $10, and I'm not making any money with Lana stock, and it's just not doing me anything. Let me purge my portfolio of this, because Lana's just not doing it for me with the chocolate. I'm like, Glenn's like, hey, I'll take a flyer on her. I'll buy the stock from him. And I sell it to him for the same $100. Did I make money or lose money? Because I had to pay the brokerage fee. I may have gotten back what I did on the stock, but I had to pay the brokerage fee to buy it through him. And he had to pay a brokerage fee as well. So you lose a little bit on the brokerage fee, but you're gambling. You're going to make more off the sale of the stock. So the idea is buy it cheap, sell it expensive. Make sense? That's the gist. Very basic. That's very basic. It gets much more involved. Mr. McDonald can give you more details on that. But that's basics of investing in stocks. I've got 4 questions for you. We got a guy named Mr. Billings, and we've got Walmart stock. All right? I want you to work these 4 problems, and we'll see how you do when you finish. So take about 6 or 7 minutes to solve these problems. Mr. Billings bought shares of Walmart stock for $120 each, meaning that was the quotation was 120. 1 year later, shares of Walmart stock sold for $138 each, or a quotation of 138. What was the percent of increase?
15%.
Good. Remember, percent increases always change over original, so that had really nothing to do with stock, right? It was just happened to involve stock. But percent increase, change 18 over original 120, 15%. All right, then it says Mr. Billings bought 6 shares of Walmart stock at a quotation of 120. He had to pay a brokerage fee of $35. So, how much did he spend on those shares of stock?
$755.
Good. The 6 shares of Walmart stock cost $720, plus the $35 brokerage fee, $755. Mr. Billings then sold his 6 shares of Walmart stock when the quotation hit 141.52. What does that mean in plain English, by the way? When it says the quotation was 141.52. Yeah, $141.52. They just don't use the dollar sign because they're lazy. So a quotation, that's just a price in money. All right, how much money did he get from the sale of his stock?
I did one extra step. So I had it, but I did one step. It was the correct answer is $849.12.
Should have been $849.12, and I think you did the next step a little early because you thought through reality. That's how much he got when he sold it. He sold it, he got a check back of $849.12. But that's not how much money he made, is it? No. Because he had already spent a lot of money, hadn't he? In the previous problem, he'd spent $755. So if he did get $849.12, what did he actually profit from the investment? $94.12. Lana, did you get all of these correct as well? All right, just a hair behind Scott. Any questions on basics of stock exchange? Very, very basics. All right, well, let me go ahead and collect those from you then. And if you would, go take out your homework. Turn to page 231. We'll continue looking at stocks and other investments a little bit over the next few lessons. Off and on. Of course, we don't do these every single lesson, but a little bit off and on just to make sure you've got a good basic knowledge here. Page 231 in your textbooks. And you did numbers 44 through 54 on page 231. Identifying different types of triangles, finding angles in triangles. It's important to remember, by the way, how many degrees are in the sum of all the angles of a triangle, huh?
180.
180 degrees. We said that if one of those angles happens to be an obtuse angle, Scott, we have an obtuse triangle. If one of those angles happens to be a right angle, Lana,
Right triangle.
we have a right triangle. And if one of those angles happens to be acute, Scott, all of them have at least one acute angle. If all 3 angles, though, are acute, Scott, then we have an acute triangle. Yeah, one angle being acute tells us absolutely nothing. We said, though, if you were to take a triangle and you were to extend one side further, you'd form an angle on the outside. What do we call an angle on the outside of the triangle, Lana?
Exterior.
Good, an exterior angle. So if we look at this triangle, we call the angles 1, 2, 3, and 4. We would call angle 4 an exterior angle. And we said, what relationship must exist between angle 4 and angle 2, Scott? They'll be supplementary, because obviously, together, they complete a straight angle, right? So they'd be supplementary. What relationship, though, must exist then, based on that, between angle 4 and angle 3 and angle 1, these two opposite interior angles, Lana?
Both 3 and 1 together is the exterior.
Equals angle 4. Good. The angle 3 and 1 together, or the sum of these, would have to equal the interior angle. We talked about different lengths of sides and things like that. Number 44 in the homework, Lana, what type of triangle would that be? 2 categories. First, it is
Obtuse.
because of the obtuse angle, as we mentioned before, but it's also scalene, because none of the sides are equal. She discovered she has a scalene right triangle in her little geometry set. Question? You don't? You have a good reason? understand that. Okay, well, you know. All right, we'll fill out the green slip then, but I think you can answer the next one without really having too much time to think. What about the next one? What are the two names for the next type of triangle?
Acute and equilateral.
Good, it's equilateral because all the sides are equal, but it's also acute because all three angles appear to be acute angles. What about number 46, Lana?
Isosceles.
Good, an isosceles right triangle. Two sides equal, so isosceles, and then of course we have the right angle. She also discovered she has an isosceles right triangle in her little geometry kit. Making that observation earlier. Number 47, finding the measures of angle 1 and angle 2. What do we get for angle 1, Lana?
80 degrees.
Good, 80 degrees, because we've already got 15 and 85, which is 100. That only leaves 80 more degrees of the 180 for angle 1. What would angle 2 have to be, of course?
100.
100, because it equals the sum of the other two. Scott, I'm going to put you on the spot here, number 48. Let's start with the exterior angle. How large must it be?
130 degrees.
Because it's equal to the sum of the 100 and the 30. Angle 2, however, must only be,
50 degrees.
because the 50, the 100, and the 30 have to together add up to 180 degrees. Numbers 49 through 54, you're supposed to draw several triangles. And good, Lonnie, you've got those there on your paper. If it could form a triangle. We're going to talk today a little bit about when and why you could not get a triangle. Number 49, I'm going to do just a quick refresher here. You would start by drawing one of the sides, probably the 2-inch side. Lana, was that your baseline on number 49?
Yes.
Start with the 2-inch side? Yep. So you start by putting your 2-inch side down here as the baseline. Again, I prefer the longest side. Then we had to put a 120-degree angle, presumably at the left vertex. Is that correct?
Yes.
Okay. And of course, it would have to be obtuse, so we're expecting an angle then that opens out this way. Did you have an angle like this?
Mm-hmm.
All right, and then from this bottom corner, this bottom vertex, we should have measured out 1 additional inch. And then just connected this point where the 1 inch ended to the end of the 2-inch line, and that would have given us our triangle. You had a triangle that looked just like that. Okay, Scott, you will have a triangle that looks just like that a little bit later on once you do this. Looking at the next one, we had just one side, so of course that has to be the base, right, Lana? The 2-inch side again.
Mm-hmm.
And at one vertex, one endpoint rather, we'll say, you had to put an angle of...
I did the 100 first.
The 100-degree angle, not a problem at all. So we line up the protractor, we put our 100-degree angle, something like that. And of course, this is not a construction, it's a drawing. A construction, Scott would only use compass and straighters. And of course, at the other end, Lonnie, you put your...
30 degrees.
And the important thing to remember is you're coming in this way. This would be 0, 10, 20, 30. So we're coming this direction for our 30-degree angle. And my protractor straight edge is not long enough. So I'm going to have to use this one here. So that way it comes all the way across to this side here. And should have gotten a triangle look just like that, if I'm not mistaken. Good. Question, Scott, as I'm going over this. All right. Look at the next one. We had 2 inches, 20 degrees, and 1 inch. Again, Lana, start with the
2 inch.
the 2 inches. And since I've already got 2 inches right here, I'm going to go with that. But the angle we wanted this time wasn't 120. It was just
it was only
20
20.
degrees. So this left end point, a very, very small angle. Nothing big to this angle at all. 20 degrees. And then again, from this left corner here, measuring out your 1 inch would have gotten you to about here. And then once again connected it out. So a very short, flat triangle here. And that's what you had. Again, Scott, any questions? We get to the next one. And number 52, something a little unusual happens, Lana. You assume you started with your 1.5 inch line. Is that right?
Yes.
And at one end, you had to draw a
145 degree.
145-degree angle. That's a very big obtuse angle. That goes all the way to here and runs into my other triangle. So I'm going to erase the triangle. Did you have an angle that jutted way out here, Lana?
Yes.
Good, okay. And 145 degrees. And then, Lana, at the other vertex you had?
Just 45.
Just 45 degrees. And so we mark our angle there. And there's our 45 degree line. Obviously, we're going to have to extend the lines to get them to connect, aren't we, Lana? I'm going to have to draw this line a lot long.
No.
Is it ever going to connect, class?
Mm-hmm.
Why not?
Because the angles are too, like, they add up more than 180.
Right. Together, they already add up to 190. They're already 10 degrees over the limit, plus you still have to squeeze a third angle in there. For them to come together, at least there'd have to be a third angle. So here's the rule of thumb. I can't just, on a quiz or test, give you whatever lines or angles I want to give you. They won't always form the triangle. I've got to make sure that the two angles I give you, if I give you two of them, together would be less than 180 degrees. Make sense? So as long as I give you less than 180, we're good. But if the two given angles add up to more than 180, well, you can't get a triangle from that. Looking at the next one, we had a ½ inch and then 80 degrees on either side. Just from this, Lana, what type of triangle am I expecting? I've got an 80 and another 80. Scott? Yeah, with two angles that are going to match, we're going to get two sides that should match as well, won't we? And so an 80 and another 80 should give me an isosceles triangle. If I can get it to complete here. And does yours look isosceles? No. Yeah. And so we got our two equal angles, so our two sides that are equal as well. And then the very last construction. Now, this was actually giving you three sides, 7 centimeters, 4 centimeter, and 1 centimeters. Now this actually goes back to what I showed you with the construction. So if you were a little confused here, I totally get it. I would start by drawing the longer side, right? The 7 centimeters. But for the 4 centimeters, Lana, the problem is, like, where do I put it? Do I put it here? Do I put it here? Do I put it, I don't know where to put it. Do you remember what I showed you could do? You could use your compass. And if I were to measure, okay, 4 centimeters would be here. I could actually take my compass, measure 4 of the centimeters here, and say, well, the other end of this is going to be somewhere along here. The other length, though, we had was
1 centimeter.
1 centimeter. I've got my ruler here, so we'll measure. For me, it's 10. I'm multiplying everything by 10. So we know the other end is going to connect over here, and the 1 centimeter is going to connect somewhere along here, and wherever these two arcs cross, that's where the top of the triangle is. Except we have a problem. What's the problem, Lana?
The 4 centimeter and the 1 centimeter together don't even equal the longest side.
Right. To have a triangle, you have to have two sides that together are bigger. So if you had like 6 centimeters and 3 centimeters, 6 and 3 together add up to more than 7. In fact, if you had 5 and 2, there's 5, there's 2. Would that even give you a triangle? 5 and 2 would lie right on top of the 7, wouldn't they? 5, 2. But if you made like 5.1 and 2.1, they'd be just a tiny bit up here, right? So technically, even if they added up to 7, you don't get a triangle. Together, they have to add up to more. And we're going to look at that as we talk about constructing triangles now. Go ahead and set your books aside. Just have out some paper and your compass and your straight edge. Just have out your sheet of paper, or 2 sheets of paper maybe, and a compass and a straight edge. And we're going to go over constructing triangles. I showed them to you in our last lesson. I want to go ahead and practice them, or have you practice them rather with me today. So constructing triangles. We're going to start with what I consider to be one of the easier triangles, and that's a side-angle-side combination. A side-angle-side combination. The neat thing I want you to write down, again, this is kind of like notes, okay, so, if you, so tuck this paper inside the front cover of your book, but the neat thing about a side-angle-side combination is any given lengths and any angle under 180 degrees will work. As long as I don't give you a reflex, well, technically, as long as I don't give you a 180 degree angle, and then any lengths I want to give you will work to form a triangle. So the side angle side triangle always works, no matter what I give you, so long as I don't go over 179 degrees. You can form a triangle with the information. What I'd like you to do is to, let's go with an obtuse angle. We don't use obtuse angles very often. Go ahead and draw a little obtuse angle with your straight edge. Not really picky how big it is. Don't measure it or anything. Just a random obtuse angle that you draw using your straight edge. That could be the straight underside of your protractor if you wanted to use that. And then draw two lines that are not the same length. Make one shorter and one a little bit longer. So we've got two sides and one angle. And we're going to construct a triangle from this information. Every triangle that we construct, you always have to start with a baseline. So your first step is always going to be to draw a big long line. So let's just get the big long line out of the way. And for every triangle we construct, you have to be given at least one side, right? Just knowing the angles doesn't tell you where your triangle is going to be. But how big, right? It would tell you the shape. Remember, angle, we do triangles similar. But we want a specific triangle. We want one with at least with a side in there. So at least one side has to be given to you. My rule of thumb is whatever side's the biggest, and if there's only one, then it is the biggest. Whatever side's the biggest is what I'll mark off on the baseline. So mark it off on the baseline. So with your compass, measure your biggest side and mark it off. We'll call the big side S. Call the big side S. Now if you wanted to, that means that all this extra space is just wasted. We could scribble that out if we didn't want it. Just scribble it out there. You don't have to scribble it out, but it just shows that I don't need that extra length there. The next thing we'll want to do is to put the angle at the left-hand corner. Almost always we'll be given an angle, and if we are, we want to put that down. So go ahead and remember, make your compass open so it fits on both sides of the angle, but open it about as big as you can. Okay, not necessarily measure, but just open it a good amount, as long as it still fits on your angle, and make your arc. Then remember, as we transfer the angle, we're going to have to make a nice, big, long arc. Make sure we got plenty of room. Remember, as you hold your compass, just hold the point of the compass. Don't hold at the top, because then you're putting pressure on both ends and the paper curls up. So just hold the point of the compass. So not up here. I hold it up here because I have to. When I'm doing it on paper, I put the point down here. Close it just a little bit here. Notice the paper doesn't pucker at all, because of all the pressure is going here. There's no pressure on that point. And you come down here, same thing. Practice just holding it at the baseline. And you can spin the paper. You can put your book all the way off your desk. It's in the way. You can put your book on the floor, Lana. It's in the way right now, being up there on your desk. Your paper bumps into it. All right, so once you've made that arc, let me get my compass out. So then you put it at the end point here, and trying to show it the way I would do it on your paper, you just spin it around in your thumb and finger. Or you can hold it down and spin the paper. All right, strategy tip. All right, you're right-handed. Start high, work low. You're trying to go counter. That's hard.
Yeah.
Swing this way. So start it on the thumb and swing it around to your finger. Okay. Now we need, of course, then to measure this angle. I need to do what, Scott?
Put the point where you on the baseline where the arc goes through.
So we're literally measuring from one intersection to the next, and then mark that length, that distance, if you will, over there. And then, of course, connect the dots. And we'll call this angle J. Call this angle J. The last thing we need to do, though, is to mark our last side. And just like as in our drawings, we would measure from the base up, we're going to take this length, let's call it L, and we need to measure this off. So, take your compass. Measure the smaller side, which you call L, from the bottom corner here, the bottom vertex, mark it off. And if you wanted to, you could scribble off that extra. So you're going to measure L from that bottom corner and mark it off. Did you already measure the angle? L is right here, Lana.
Oh.
It's this line. You're measuring from the bottom up. Just put the point down and make a little mark on your paper. Okay. And then, to finish the triangle class, we just connect those two opposite dots. Notice I have a side, an angle, and a side. I'm going to connect the opposite corners right there. And there's my side angle side triangle. With Lana as the little side, Scott as the big side, and Joshua, who's not actually with us today, in the middle. All right. Or you could say L is for large since it's the small side, and S is for small since it's the large side. But that would be counterintuitive. Questions on the side angle side. You mark the big side. You copy the angle over, and you mark the smaller side. Let's practice for the next type of triangle, either on the back side of that paper, maybe if you still have some room. Let's look at an angle side angle triangle, an angle side angle arrangement. Now, the key here is you've got two angles. So the sum of the angles must be less, be less than 180 degrees. If you're given two angles whose sum is at or greater than or equal to 180 degrees, this ain't going to work. So I can't be like, yeah, let's do a 100-degree angle and a 94-degree angle. It wouldn't work, right? You got to make sure, as we saw in the homework, the angles add up to less than 180. So let's play it safe. Let's do a big acute angle, something that's nearly a right angle. So a really big acute angle. And let's do a smaller acute angle. Because I know as long as they're both acute, I know I'm not going to go over 180 degrees. Okay? And then now let's also give ourselves a side that's maybe, I don't know, looks like a couple inches long. So we've got our one side and our two angles. Once again, every triangle construction has to begin with sorry, Josh. I'm a terrible camera person. All right, there we go. Every triangle construction needs to start class with a long line, our baseline. So start with the baseline. Now, it doesn't have to be super long, as long as it's bigger than the line that you're given. Okay, so it doesn't have to be enormous, just bigger than what you started with. Make sure you're working on something, Glenn. All right, and I told you we're always going to start by marking off a side. I said use the biggest side. Well, there's only one, so he wins by default. Okay, and so we're going to start by measuring the side that we are given. Start at the end point, mark it off, and then as desired, scribble off the excess. I'm going to call the side C. Lowercase, of course. What do you suppose we do next, Lana? two angles and one side.
Don't we like draw an arc or something?
Where do we draw the arc?
On
On
the bigger?
the angle, either one really. But yeah, we're just going to pull this angle and put it right there. So that involves taking a little arc here. And we not only make an arc on the angle line, but while our compass is open this certain amount, we're also going to make an arc on the line down here. So make an arc on the angle, and then make an arc down here at that end point. Of course, we have to measure across the angle. We're trying to copy this distance here. So measure that angle and mark it off. Now, when you connect the dots here, you're going to want to make the line long enough that you're guaranteed to get these lines to cross. So don't be skimpy. I'm going to call this angle capital A and mark it down there.
The angle that small. How do you get the arc that small?
What do you mean, how do I get the arc that small?
Like,
okay.
Oh.
So on the end point, notice how I kind of spin the paper a little bit too?
Oh.
It's fun to spin the paper.
I kept putting the end point like here.
No, on down here. And then when you measure, you're going to measure from this point to right there. And I'll even make a little mark. Do you see how it went right through? And see how we did it here? And so now these 2 points will connect to finish the angle. All right, what do you think we do next here, Scott? Do it again, right? But with the other angle. If we call this angle B, I want to put angle B right here. But with an angle side angle, you're going to reverse the second angle. I don't want the other angle to go out like this. I want the other angle to go in like this. So you still make that arc on the angle. But when I come down here, I'm going to reverse the compass and make the arc the other direction. So you make the arc on the angle and then reverse it. You're still going to measure the arc you made, but make sure you come to this arc here. Not the old arc. That's so last angle. This arc. We got to keep with the times. We're going to put the compass here and measure off on the new arc we just made. Does that make sense? But we are still completing this angle. So we're going to connect this intersection down to this corner and connect the dots. And there's my angle B. And I've got an angle, a side, and an angle, and there's my triangle. Questions on the angle side angle combination? Questions on the angle side angle combination? All right, the last one is one that I showed a little bit ago, and that's the side, side, side combination. And as Lana pointed out, the sum of the two small sides must be greater than the one large side. The sum of the two small sides must be greater than the one large side. Otherwise, you can't get a triangle. So as you draw your lines, let's start with a long one, then go smaller, but not too much smaller, and then another one that's maybe medium size, so that together the two littles will add up to more than the big. Let's call these lines X, Y, and Z. So I have a long line, a small but not too small, and a medium. But every triangle construction is going to begin with
A line.
big long line. And again, not huge, just longer than X. Okay, X is my biggest, so we just need to make sure it's bigger than X is. And that looks like it's bigger than X, I think. And then like all the other constructions, you start by Start by measuring the longest side and marking it off. I'll go ahead and label this as side X, and I'll scribble the excess. Now what makes this one so unique is there are no angles. So I don't know where any of my other sides are. They could be wherever. So Scott, what do we do next? Measure one of them. Which one?
Z.
Okay. So you measure one of them. It doesn't really matter which other one you measure. Okay. Ooh. Careful. Okay, I got it. So measure one of them.
And then you make a big arc on the other one.
Good. We come down here, and since we don't know where the other line will go, we just draw a big sweeping arc, because I know that the other one end of Z is going to go down here. The other end of Z, I don't know, somewhere along here, somewhere along this path, right? All right. Now then, Lana, what do you suppose we do next? We measured X, and we marked it off. We measured Z, and we kind of showed where it might end up.
We measure Y.
Measure Y. It's the only one on the left, right? So measure Y, but we also don't know where Y goes. But, Lana, I know this. Y ain't connecting down here. This is where Z connects. So where does Y have to connect? Over here. So we're going to do the same thing with Y as we did with Z, but we're going to put a point of the compass down here. And same thing, somewhere along here is where Y has to go. Well, notice where they meet up. So Y could go right here, and Z could go right there, and we just connect the dots. For Z, connect there, and for Y, connect here. And we've got our triangle. Now if you look in your textbooks, once you finish, you look in your textbooks at page 226. Page 226 in your textbooks. Get your textbooks back out. You notice they give you a side A, there at the bottom of the page, a little side B, and an angle C. Now, they do it a little bit differently than I do. I start with the side A, then I copy the side C, and then I will mark off the side B, okay, to end up with that triangle. I think that's a little bit more direct way. The angle side angle triangle you see at the top of the next page. They start with the little side B, they put an angle A, and then they put the angle C. Notice how C goes backwards. Now they started with C going backwards already. That's an option I suppose as well, so we just could copy straight down. And then for the side, again, mark off the A. B just got this dotted line arc. C got a little red line, dotted line arc. And wherever they connected together, met up together, you see on the next page connecting those down. Okay, so some diagrams there for you as well. For homework this evening, look over at page 228. In the homework, the little tiny homework section, notice there's only 3 problems in the homework section. They're going to have you construct a triangle using lines A, B, and C from further up, right above that. You see up where it says practice? They have A, B, C, and D. Well, you're going to use A, B, and C to make a triangle. Then number 2, you're going to use the angle 3 and angle 2 and line B to make a triangle. And then for number 3, you're going to use line A and line D and angle 1 to make a triangle. Do we understand what we're doing in the homework? So you're going to do those 3. So for homework, page 228, homework 1 through 3, and also on page 282. Also on page 282, you want to write this down because you're never going to find it later. So page 228, 1 through 3 on the homework. And on page 282, do numbers 39 to 46. Page 282, numbers 39 to 46. That's in addition to page 228, numbers 1 through 3. All right, take a look at that tomorrow as we wrap up this portion of geometry. We'll go into a new section of geometry starting tomorrow, Lord willing. All right, you are dismissed. Have a wonderful rest of